Okay, guys, take 1 more minute. I think this should be done by now because it's not a very tough question. Like when you're choosing a functional group, then like what's the correct priority here? I've got two answers. By the way, is my voice clear and my screen visible properly? Tell me about my voice. Is my voice clear?
Yes, sir, it's very clear.
Okay. Now, okay. See, I think आप लोग को इसके बारे में नहीं पता होगा. Like, what is the priority order? After you must be confused regarding these two, amide and oil halide. Right? This is amide, and then you have oil halide. If you look at this order, the correct order for amide and oil halide is first of all you have oil halide C double bond O Cl, and then you have the amide C double bond O NH2. Okay, this comes later. C double bond O NH2, it comes later. Okay, so if you look at the orders, will be not right. Okay, this is fine. Cl NH2. This is not. Also, if you see this is also not right because oil halide is having higher priority than the amide carbons. Okay, so in that case, only this option is correct. SO3OH is the maximum, like it is the having highest priority, followed by the oil halides, that is oil chloride in this case, and then the amides, and then the nitride. Okay, so if you want to write the complete order, please also write the complete order. Some space. Okay, so COH, then you have the sulfonic acid, then you have the ester, you have oil halide, then you have amide, you have nitrile, aldehyde, ketone, then here you have NH2, and after NH2 you will be having OH. After NH2 you will be having, I mean after ketone you will be having OH, and then you will be having NH2 at last. यहाँ पे OH आएगा पहले, उसके बाद NH2 आएगा. ठीक है, please write this down. चलिए, moving on. Try this. Correct IUPAC name for the following. I will give you 2 minutes for this. Okay, याद. No, try once again. Yeah, I think that's not right. Try once again. You choose the correct function and then you once you start numbering the parent carbon chain, you get so you don't have to do the complete thing also. आप identify कीजिए and if you are choosing the parent carbon chain and you are starting the numbering from the right side, you will get the answer quickly. Please identify the functional group and then only start numbering it. Okay. Tell me guys, what is the functional group? ना एक एक करके हम पूछते हैं. Fadil, what is the functional group here in this compound? Yes, Tarif, correct option. Fadil, जल्दी बताएं. Tell me, just tell me yes or no. If you don't know, then tell me you don't know. Fadil, अच्छा Fadil type कर लूंगे. Maria, functional group. Tell me, what's the functional group here?
Aldehyde.
Aldehyde. Okay. Don't know Fadil. Okay, fine. What about you, Maria? Functional group. Functional group, Matiha. If you don't know, then please say don't know, so I can move on. Tarif, tell me. माइक ऑन करके बताएं जल्दी माइक ऑन करके बताएं ना बहुत टाइम लग जाता है ऐसे यस अच्छा तारीफ है आंसर देश को हटाइए शाहिद टेल मी व्हाट्स द फंक्शनल ग्रुप शाहिद फंक्शनल ग्रुप आपकी आवाज नहीं आ रही शाहिद माइक अच्छा गाइस प्लीज हैव योर माइक्स करेक्ट नाइट्रो ओके व्हाट अबाउट याद याद आपको भी लगता है नाइट्रो इज द फंक्शनल ग्रुप आई थिंक
यस सर
ठीक है देखिए नाइट्रो विल नेवर बी फंक्शनल ग्रुप ठीक है मतलब at least in the context there is only this many functional groups ठीक है carboxylic anything that is having a suffix we will treat them as functional group in IUPAC nomenclature context of IUPAC nomenclature if it does not have any if it does not have suffix it only has a prefix then we will say that it is a substituent it is never a functional group so similar in that case nitro will never be a functional group because it does not have any suffix it only has a prefix similarly chloro bromo iodo fluoro all of these things will also never be a functional group they will only be prefix as a substituent they will be acting as a substituent similarly or alkoxy groups okay in this case the functional group is what the functional group is aldehyde here we have two groups which can act as functional group. One is this aldehyde group and the ketonic group. Now then we have to choose the priority. If I look at the priority, and what is having the major priority? CHO is having the higher priority, right? So we'll write CHO is our functional group. For CHO we write AL. Then we will look at the unsaturation. The unsaturation is what? There is a double bond, right? And for the double bond, what do we write? We write EN. The only till here you have to do, and then you have to start numbering it because have identified each and everything correctly. Their numbering is only different. Methyl nitro oxo have enal. Methyl oxo nitro have enal. Methyl nitro oxo have enal. Formyl is the same thing. Well, it is regarding CHO, but they have identified almost the similar things. So we have to check the thing now. Numbering starts from that carbon and which is this to the functional group. So numbering can't start. The numbering will start from here, here, or here. These are the terminal carbons. From here only we can start the numbering. If I look at the carbon atom, let us suppose this is A, this is B, and this is C. C carbon, it is that carbon which is containing the functional group. That's why the numbering will start from here. So I will have this. Now, should I go right or should I go up? So obviously I have to go, sorry, left or up. So I have to go left side and then go up. So this is the longest carbon chain and you start number. This start from the carbon which is nearest to functional group. Numbering also starts from there only. The numbering will be like this. One, let me choose some other color. 1, 2, 3, 4. And 5, 6, 7. So as soon as you have numbered, you will see that you have 3 oxo. 3 oxo. Then you have fourth carbon has a double bond. So 4 in में तो सिर्फ एक ही है. All of them are saying that is 3. That means they're numbering from here 1, 2, 3, 4. But the correct numbering will be from the, it will be from where? It will be from the aldehyde. Okay. So you will write it like this. This is the correct option. 4 methyl, 6 nitro, 3 oxo, hept, 4 enol. Okay. So this is the correct option. You can see that 4 methyl, 4 en. Okay. So please copy this down. I have written this down. Try this. So the following structure are aromatic in nature. For aromaticity, what are the conditions? For aromaticity, the first thing that you should see that all the carbon atoms, all carbons are in plane. Now, when I see all carbons are in plane, that means all carbons should have sp2 hybridization. Okay. Second is there should be a ring, complete delocalization. Okay. So when you have sp2 and ring, then it will be obviously complete delocalization. And 3 is 4n plus 2 pi electrons. Okay. That means where n is equal to 0, 1, 2, or 3 like that. So if you put 0 here, then you can have either 2 pi electrons. Okay. You can have how many pi electrons? Pi electrons should be equal to either 2 if you keep 0. If you keep 1, then it will be equal to how much? 6. If you keep 2, then 4 to the 8 and then 10. Okay. And then for 4 more, then you will have 14. So like this, you have to go. So pi electron should either be 2, 6, 10, or 14. Please try this down. Okay, Tari. I will give you guys take 1 more minute, not much. Because if you see, you have to eliminate a few things. ना यहाँ पे आपको eliminate करना है सिर्फ. ठीक है, आप eliminate कीजिएगा, आपको आंसर मिल जाएगा. ओके याद. By the way, इसको हम ना एक चीज बता देते हैं. Maybe you guys are not seeing this correctly. This is the negative sign, ठीक है ना? This is positive sign. This is again negative sign. So negative electrons, I mean the negative sign will only be there because of the lone pair electrons. And lone pair electrons are also pi electrons. ठीक है? तो उसका ध्यान रखिएगा please. Lone pair electrons are also pi electrons. Yes. ठीक है, चलिए देखिए यहाँ पे. See, first of all, you will look at the carbon number A. First of all, I look at electrons and I look at this. Okay. If I look at the number of electrons, then number of electrons it is equal to how much here? Number of electrons it is equal to 6 because 2 electron here, and 2 electrons for the lone pair. Does this make sense? Yes or no? Please tell me. Fadil, Maria, Madiha, Tarif, Shahid, Aniyar.
Yes.
जल्दी से बता दें एक बार. Quickly tell me yes or no. 6 electrons. Yes. What about others? Maria, Madiha. हाँ ठीक है. I can repeat. I can. Wait a second. I'm saying that I'm calculating the number of electrons we are having in the system, and not only the electrons, but rather number of pi electrons. So in that bond, there are 2 electrons. This bond is having 2 electrons, and due to the lone pair, negative charge will always be present because of a lone pair. So this negative charge it was also having 2 electrons. So in total, we are having 6 electrons. Does this make sense now? Pardon? ठीक है, माइक ठीक नहीं हुआ आपका अभी तक. Similarly, if I look here, अच्छा, now I will look whether it is sp2 or not. So if I look at this carbon atom, it is having one double bond. See, अच्छा, एक और चीज आप यहाँ पे देख लीजिए. All single bond, that means it will be sp3. If there is one double bond, just give me a second, guys. Okay, when you have one double bond, it will be sp2, and when you have one triple bond, it will be sp. Okay. So these are the different things that you can remember. So this is having one double bond, so it will be sp2, one double bond sp2, one double bond sp2, one double bond sp2. Now, what about here? It is only having what? It is only having single bonds, but you can see the total number of bonds in this case will be only 3 because there is a negative charge here. So yeah, either you have a positive charge or you have a negative charge. It will always be having 3 bonds. Okay. Like how do we get a positive charge? When a bond breaks and the atom which was connected, it takes the electron. And when we get negative charge on carbon atom, when the bond was present and when the bond broke, carbon retains its electron. So that in that case, we get the negative charge. So this is also having got only 3 bonds. And when we have 3 bonds, it will be sp2. So all of these are what? sp2 hybridized. So this is going to be aromatic. If you look at this one, here also, if you look at all the bonds here, sorry, all the carbon atoms, they are going to be sp2 hybridized because all of them are either having a double bond or they're having a positive charge. And when I look at the number of electrons, so this is 2 electron, this is 2 electron, this is 2 electron. This positive charge, it means that there is no lone pair here. Right? Positive charge मतलब आपकी lone pair नहीं है. So here also we are having n is equal to 6. Now when I come to the structure that is C structure, I see that instantly there is this 2 carbon atoms and these are sp3 hybridized. They don't have any double bond, they don't have any charges also. Okay, so both of these are sp3 and that is why there will be no complete delocalization. Even in this one ring also there will be no complete delocalization. So this cannot be. Okay. So what are, so this cannot be, this cannot be, this cannot. C option है ना, तो only B you have to choose. Does this make sense? Yes or no? Please tell me. D फिर आपको देखना भी नहीं पड़ेगा. Otherwise, if you look at the D options also, here you have two electrons, two electrons, two electrons, and here you are having two electrons. So total number of electrons is equal to 8 electron, and 8 electron is not in the list for which we have aromaticity. Does this make sense? Yes or no? Please tell me. Maria, Madiha, याद आपको समझ में आया?
Yes, sir.
ठीक है. Please copy this down. Chलिए, moving on. I hope you have written whatever is needed. Okay, try this one. You forget about the two E's one. आप बाकी सब चीज देखिए सही है नहीं, ठीक है, and then you can choose an option. E and Z nomenclature, it is for the double bond. Uh, you know that double bond can be in two different ways, ना? Double bond या तो आपको ऐसे मिल सकता है, ठीक है, or it can be like this also. ठीक है, so if it is like this, then it is known as E, and if it is like this, then it is known as Z. ठीक है. So these are Z and E nomenclature. Cis and trans की जैसा ही है, बट लेकिन cis and trans तब होता है जब you have same groups, like इधर भी मिथाइल है, तब हम तो यूज कर सकते हैं. But if you have different groups, then we use E and Z. शायद let's take 2 more minutes. Okay, Fadil. Okay, Maria. I think most of you have figured two options, and you must be confused on those two options. So you can write in the chat that too. If you're confused between either, sorry, you can write A or B, B or C, C or D, B or D, A or D. Okay, so any combination you can write. So I understand like where your problem is. So if you have cracked up to two options, then please write those two options also. Okay, Father. Actually, so time is almost over. See here, guys. First of all, if you look at the functional group, there is no functional group here. And in the way of SPUF, that is substituent parent unsaturation functional group, when you don't have any functional group, we represent it by the letter E. And we will look at the double, then you look at the unsaturation. That means if there is any double bond or triple bond. So yeah, we have both of things. We have the double bond as well as the triple bond. So double bond is written first and then the triple bond. The logic behind this is the double bond, it is represented by En, the triple bond, it is represented by Yn. So alphabetically speaking, if you remember substituent co, when you have multiple substituent, how do we arrange them in the name? We arrange them in the alphabetic order. Similarly, here also, when you have multiple unsaturation, like you have double bond and triple bond, these are the only two unsaturations that are possible. So you will also write them in the alphabetical order. So you will have En and I. There will be En with some number, and then I will leave some space, and there is also Yn. Okay, so there is some numbering that we have to do. So double bond first, and then the triple bond. This is a major confusion for the people who study IPAC nomenclature, where the unsaturation itself, it is treated as one of the suffix. So if you use that format for suffix, in the suffix part, En has a higher priority. That means, yeah, like if the double bond is there, then you start that carbon atom, so on. Okay, those things are there. But like writing the name, it is En comes first and Yn comes later. Okay, so you may be confused because of that. Now let us look at the next thing. Like even from here, I can start doing the answer and it will be obviously fine. The parent carbon atom, see, I will not even write like what I will not even count because all of them are saying hex. So I will assume that hex 6 carbon atom is correct, right? So it will be hex. And if I look at the substituent, then the substituent is only one, that is Br, and we write Br as bromine. Now, when I have to start numbering, obviously, we start numbering from that carbon atom which is nearest to the double bond. So which carbon is nearest to the double bond? This carbon is nearest. So we'll have 1, 2, 3, 4, 5, 6. Bromine is in the second position. X, the double bond is in the second position, and the triple bond is in the fourth position, and that's it. We have 2 bromo, X, 2, 4 ion. So you have 2, 2, 4. देखिए 2, 2, 4, 5 है तो ये नहीं होगा 2, 4, 2 ये नहीं होगा 2, 2, 4. This one is the correct option. 5 है तो नहीं होगा. ठीक है. So I hope B और C में आप लोग थोड़ा confuse हो रहे होंगे. ठीक है. So it is B actually. It is going to be 2 bromo, X, 2 in, 4 ion. Now this 2E suggests that this double bond that is present in the second carbon, it is in the E configuration. Now we can also have this in this type of thing. ना? ये आपके पास ऐसे रहता. Br, and here is a CH3. Okay, so that would be a Z configuration because alkyl groups are here. Try this. Arrange the following in decreasing acidic strength. So decreasing acidic strength, why it is acidic? It is acidic because of this OH, right? Because of this OH. Whenever you have to look at the acidic strength, understand that once shows acidic nature, it will form a phenoxide ion. Now, obviously, whenever you are having a negative charge or a positive charge, that compound will be unstable. So then you have to look at, okay, which one is the most stable out of these unstable conjugate bases. So we have to decrease the, what you do want, we have to decrease the negative charge. Lower the negative charge, higher is the stability. And what would lower the negative charge? Electron withdrawing groups are going to lower the negative charge. So if you have electron withdrawing groups, then that will be more acidic. So we can say that acidic strength directly proportional to the stability of conjugate base. The stability of conjugate base, it is directly proportional, or rather I should say it is directly proportional to the electron withdrawing group. Okay, present. The higher the number of electron withdrawing group, higher will be the stability. So I have got one answer. Okay, Father, you see. No, try once again. That is right. So take 2 more minutes, guys. Yes. Good, correct. If you can see that which is the most, like which particular compound is going to have the highest electron withdrawing capacity, then you can answer no. Yeah, try once again. Think about in the terms of like when something is in para and when something is in meta, like what happens, whether it shows mesomeric effect or not, shows mesomeric effect. Think in those terms. Also, this question is also boards level only. Right? This question is not, I would not say that it is complete JEE, it's like boards only. In boards also you have this type of question. And these questions, they generally come for 1 marks or 2 marks. If they like, this will be only for 1 mark if you have to give the order. But if they ask like also explain, then explanation will be of 2 marks or 3 marks. But if you are only writing the order, then this is generally in 1 marks. This is done. Now, I will first of all write what are the different effects of each group. So when you have NO2, NO2 is a minus M group and only minus M group when it is present in the ortho position or para position. It is in the para position right now, so it will show minus M effect. But if I look at the NO2 here, this NO2 group on it itself, it is a minus M group, but when it is present in the meta position, it cannot show the minus M effect. Why? Because when it is like resonance is happening, positive charge does not come to this particular carbon atom. On the meta carbon, it does not come. That is why it does not show any mesomeric effect if it is in the meta position. So it will only show minus I. Now OCS3, again, it is essentially a plus M group because it is having a lone pair electron. This oxygen atom, it will be having a lone pair. But when it is present in the meta position, it cannot show that plus M or minus M. It cannot show mesomeric effect. That is why it is going to act as minus I. Okay. Now, then we have what? Then we have the D1, that is OCS3. So it is obviously going to act as plus M. So the least stable that you will be having is D, and the most stable will be A. So do we have most stable A? Yeah, we have most stable. And next stable will be B. Why? Because NO2 is obviously more, it has more electron withdrawing capacity than OCS3, because in OCS3 we have only oxygen atom that is electronegative, and minus the inductive effect, it depends completely on the electronegativity. So in OCS3, we have only 1 electronegative element, and in NO2, we are having 3 electronegative elements. That is why the electron withdrawing capacity of NO2 will be much higher than that of OCS3. Okay, does this make sense? Yes or no? Please tell me, guys. So one thing that you have to note down is Mesomeric effect only works on ortho and para positions and not on meta position. ठीक है, explain this point. Correct stability of the order of carbocation. Now the C option is a bit differently written, तो ये मतलब नहीं समझिएगा तो C वाला ही सही आंसर है, ठीक है. You have to see, I mean you have to check and tell. वो बस ऐसे पता नहीं क्यों लिखा होता उस वेबसाइट में. I think because of this thing. I mean these can be typed, but this have to be drawn. Because it is having a branch like this. So maybe that's why, but I don't know. So let's try this. I hope you can do this, guys. 1 degree, 2 degree, 3 degree नहीं हो जाएगा. पढ़ाई होगा. Yeah, I've got 2 answers. Okay, yeah, and Maria. ये काफी आसान है, देखिए 1 डिग्री 2 डिग्री 3 डिग्री देखिए हो जाएगा. Okay, Fadil, we take 1 more minute, guys. प्लीज लेबल कर लीजिए 1 डिग्री 2 डिग्री 3 डिग्री हो जाएगा अगर, तो उसमें क्या ही है. ये देखिए, तो सबसे पहले ऑप्शन देखते हैं हम लोग, CH3 होल थ्राइस सी पॉजिटिव. ठीक है तारीख. So that is 3 degree. Then you have this as 1 CH3 attached to carbon 1 degree. You have 2 degree. So obviously it is not correct because 1 degree से ज़्यादा stable 2 degree होता है. Let's come to the next one. This is 3 degree. This is 2 degree. This is 1 degree. This is 0. So this is correct. 1 degree is most stable, not possible. 1 degree most stable, not possible. So you have seen all the options, and B is the correct one. ठीक है, फिर सर करना था, मतलब मात्र आपको 15 सेकंड लगेंगे, 20 सेकंड लगेंगे, ज्यादा ज्यादा 30 सेकंड लगेंगे, बहुत हो गया तो इसमें. चलिए मूविंग ऑन. The correct order of reactivity in electrophilic substitution reaction is following. What is the question? Yeah, but like you instead of this positive charge, आपको यहाँ पे ऐसे होगा CH3 whole thrice carbon which is attached to Br, है ना? CH3 whole twice CHBr. तो यहाँ पे ऐसे इस तरह से अटैच होगा any halogen atom, ठीक है? And then they will ask regarding the SN1. Try this. We have done this type of question in the last class also. Electrophile सबसे आसानी से किस पे अटैक करेगा? The one which is having the maximum electron density. तो इलेक्ट्रॉन डोनेटिंग ग्रुप आपको देखना है यहाँ पे बेसिकली. सो एक बार में आंसर आ जाए. चलिए देखिए, आई थिंक मे बी एक बार में आंसर आ जाए, 2 बार में आ जाए, बहुत हुआ तो. Electron donating group you have to see. Electron donating group. Please remember, you don't have to see ortho para, you have to see electron donating. Electron donating और electron withdrawing से आपका आंसर आएगा इससे. Very good, both of you. Adil and Shahid, very good. Yeah, got more answers. That's pretty nice. Yeah, very good. So see here, these. CH3, it is what? It is plus M group. Rather not, I should write plus M, but I should write that it is electron donating group. Okay. Chlorine, it is electron withdrawing group. Even though it gives ortho and para substituent. Okay, ortho and para products, but it is electron withdrawing. This is also electron withdrawing. This is what 0, I mean, it does not have it. So electron donating will be the highest. I mean, it will react with electrophile most easily, followed by A, then followed by, if I compare C and D, then obviously C is going to be less. It will have less strength of electron withdrawing capacity, and O2 will be maximum. So it will be BACD, and all of you have done it very correctly. Very nice. So you try this one. So the ascending order of acidic strength. So here also you have to do the same thing. यहाँ पे आपको देखना है कि you remove the hydrogen and you will get a carbon ion. So this carbon will be having negative charge, this carbon will be having negative charge, this carbon will be having negative charge, this carbon will be having negative charge. Now, which of the following carbon ions are the most stable? जो सबसे ज़्यादा stable carbon ion होगा, that will be the most acidic. Please do this. This can also come in hydrocarbons chapter because alkene, alkene, and alkynes है यहाँ पे, ठीक है? So you can treat this in hydrocarbons also. Application of GOC, that is the GOC2. GOC1 में हमें क्या पता है? GOC1 में पता है nomenclature हो गया, फिर उसके बाद electronic effects हो गए, ठीक है? Then we have isomers हो गया, ठीक है? So these things are GOC1 in organic chemistry 1. In GOC2 that we have, GOC2 में basically होता है the application of whatever we have learned in GOC1. यहाँ पे acidic strength आ जाएगा, यहाँ पे आपके पास stabilities आ जाएंगी, यहाँ पे आपको attack of electrophile, nucleophile, and the strength of electrophile and nucleophile आ जाएगा, ठीक है? So all of these things, so they are now you have started to touch the different chapters here. Okay, आप धीरे-धीरे थोड़े-थोड़े कुछ chapters को आप touch कर रहे हैं, and then you start with halocene, halorine, and so on. चलिए try this, इसको भी कीजिए, हो जाएगा यहाँ पे. You have to look at the hybridization of the carbon atom, and according to the hybridization, if you remember electronegativity जब हम लोगों ने पढ़ा था, वहां पे हम लोगों ने बताया था कि like which is most electronegative, sp, sp2 और sp3 में, ठीक है? So you have different hybridization of the carbon atom, and according to the hybridization, you can arrange arrange them in the electronegativity, and the one which is having higher electronegativity that will bear the negative charge more effectively. Basic ये है. अब apply आप लोग कीजिए, लेकिन you have to apply. It is a negative charge. Negative charge अगर आप देखिए तो नेगेटिव चार्ज है. नहीं नहीं, आप बिल्कुल ही गलत जा रहे हैं. सुनिए, ध्यान से सुनिए. Negative charge may, if you are going to have CH3, CH3 and CH3, they are going to give more electrons. When they give you more electrons, then the negative charge will increase. If the negative charge will increase, then it will be more unstable. It will not be stable. Okay? So when you remove the hydrogen, the carbon ion should be stable. Then we will have the highest acidic strength. Okay? I hope it makes sense now. Stability of, देखिए, हाँ ठीक है, असेंडिंग डिसेंडिंग मत कीजिए. यहाँ पे तो साइन दिया है ना, फादल. ए सबसे ज्यादा, फिर बी, फिर ऐसे दिया है ना उसमें उन्होंने तो. असेंडिंग डिसेंडिंग तो तब होता है जब सिर्फ कॉमा रहता है. जी. ओके मारिया. मारिया, कैन यू लाइक लुक एट इट वंस मोर? एक बार फिर से देखें. Take one more minute, guys. And I will explain this. Oh, Shahid, no. Try once again. शायद नहीं, शायद सही नहीं है. लाइक सबसे पहले तो इलेक्ट्रोनेगेटिविटी आपको देखना है ना. The one which is more electronegative, which is more electronegative, sp, sp2 या sp3. अगर यही में आप अगर गलती कर रहे हैं तो you will have to visit back the periodic properties chapter. ठीक है, sp, sp2, sp3. वहां पर मैंने बताया भी था कि इसका ज्यादा होता है, क्यों होता है. Which hybridized carbon atom will be more electronegative and why? Explain both the things. Yes, correct, father. Yeah, correct. Yes, Marian, how it is correct. I hope आपको खुद से समझ में आ गया ना, Marian? What was the mistake?
Yes, sir.
ठीक है. Yes, father, that is right. Okay, चलिए. Time's almost over. Let me explain this. So first of all, regarding the electron negativity, Sp is going to be the most electronegative, followed by Sp2, and then followed by Sp3. Why Sp2 is more electronegative? Because it has more percentage S character, and when you have S character, it will be more near to the nucleus, so the electrons will be more attracted by the protons, and hence it will be what, it will be more electron. So it can be attracting the electrons if it is present in S orbital very easily. So if Sp is most electronegative, that means it can bear negative charge easily. So यहाँ पे if you look, then A carbon is what it is, Sp. Second, this is Sp, this is Sp2, this is Sp3, this is also Sp3. So like we can already see that then first of all we have A and then B and then you have C or D. So A maximum कहाँ पे? C and D option. A, B भी same है, उसके बाद D, C में देखना. So if you look at C option, the C option is what it is having electron donating group. So these electron donating groups are going to release electron toward the carbon atom, making the negative charge even more high. If the negative charge will increase, obviously the stability will decrease. So that's why the C will be the least stable. So here we are having option number 2. ठीक है. अगर आप उल्टा चलते हैं ना तो बहुत आसानी से आपको मिल जाता. Like if you looked at only the one which is least stable, तो यहाँ पे C आ जाता, right? Because it is 3 degree. 3 degree कार्बन आयन है, लेकिन कार्बन आयन रहता तो स्टेबल होता. If it did not have electrons, it is having extra electrons, तो उसमें आप भी और इलेक्ट्रॉन दीजिएगा तो it will become unstable. So moving on. Try this again. The acidic strength here also you have to apply the same thing. ठीक है. Please do this. Oh my God. Should I explain? I think I need to, huh? Also, you have to look at the electron withdrawing capacity. No, you have to look at only the electron withdrawing group. So which one is having the most number of electron withdrawing group? Obviously B. Then next one will be B, and after that it will be D, because again fluorine. D. So B and D. Yeah, option number C will be the correct one. Does this make sense? Because what will happen when you have COOH? COOH, it will ionize into COO negative. So you will again have what? You will again have the negative. ये तो बिल्कुल बोर्ड्स वाला सवाल है. बोर्ड्स में इसमें तो एनसीईआरटी में इस तरह के सवाल है. अरे भाई क्या हो गया? एनसीईआरटी में इस तरह का सवाल नहीं है. आप लोग ना जेई का बस ऐसे जेई जेई का सवाल. आप लोग का सारा दिमाग उसी टाइम में होता है. Okay. बिल्कुल एकदम हम बोलेंगे ना, दिस इज कंप्लीटली बोर्ड्स. बोर्ड्स भी नहीं, एनसीईआरटी. कमाल क्या. देयर इज वन क्वेश्चन. कौन बच्चा होगा, मतलब एटलीस्ट इसने हमसे पढ़ा है, लेकिन सभी ने किया होगा भाई. मतलब हमसे पढ़ने की बात ही नहीं. मतलब if you have done years, which of the which acid pair shown which acid of each pair shown here would you expect to be stronger? The same thing ना, यहाँ पे तो उसी तरह के सवाल है. yes or no? बोलिए. फादिल, मारिया, मदीहा, तारीफ, शाहिद, यार
Yes, sir.
सारे उसी मतलब एग्जांपल है ना. देखिए SCF3 है, ठीक है. देन यू हैव ये CH3 एंड CH2, इसमें कौन ज्यादा होगा? CH2F और Cl वाले में कौन ज्यादा होगा? सारी चीजें तो हैं ऑलमोस्ट. ये तो होना चाहिए. मतलब देखिए प्लीज आप लोग ना इस तरह से मत घबराइएगा कि ओ माय गॉड मीन्स है. बोर्ड से पर्सपेक्टिव है, बोर्ड एग्जाम देने जा रहे हैं, उस तरह से सोचिए तब तो और अच्छी हो जाएगा आपका. ठीक है, तो ज्यादा आप लोग लोड मत लीजिए. होना चाहिए था ना मारिया, ये सुनो, होना चाहिए था कि नहीं?
Yes, sir.
है ना? ठीक है. हाउ मेनी ऑफ यू फील दिस प्रेशर? टेल मी गाइस, रेज योर हैंड. मतलब वही सवाल अगर आपको बोर्ड्स में मतलब बोर्ड्स के पेपर में दिखता है तो फिर आपको लगता है अच्छा ठीक है, लेकिन मेंस का देख के रेज योर हैंड. Like if your mind goes blank when you just see okay fine JEE, don't, you're not even looking at the question, but you're getting anxious because it is JEE. कोई नहीं तो फिर हुआ क्यों नहीं है? ये होना चाहिए था फिर तो. Now if you get like that, if you get in that phase ना, कि आपसे मतलब अगर JEE का सवाल देख के नहीं होता है, उसमें ना एक चीज जो मतलब sounds आप लोग को, it will sound very cringe to you guys, but what really helps is ना affirmations. ठीक है, ठीक है. Please look at yourself and like when you are alone also ना, then just say, keep saying to you, JEE is easy, JEE is easy, JEE is easy, JEE is easy. JEE में बोर्ड टाइप के सवाल आते हैं, JEE में बोर्ड टाइप के सवाल आते हैं, JEE में बोर्ड टाइप के सवाल आते हैं. ठीक है. इफ यू कीप सेइंग दिस थिंग्स ना, देन आपका माइंड प्रिपेयर हो जाएगा. देयर आर टू टाइप्स ऑफ थिंग व्हिच हैपेंस. दो पाथवेज होते हैं. ब्रेन टू बॉडी. ठीक है. ब्रेन टू बॉडी का मतलब क्या? ब्रेन डज समथिंग, ब्रेन बोलता है कि ये करना है तो फिर बॉडी उसे करती है. जैसे फॉर एग्जांपल आपने देखा होगा बच्चों को या फिर इन ओलंपिक्स आल्सो, इफ समवन विंस रेस, व्हाट डू दे डू? They will extend their arms, right? Whenever somebody takes a wicket, they will extend their arms. So like they are not at all what I can, they are completely confident, है ना? और ऐसे वो डरे हुए नहीं है. Like if you open your arms ना, if you open your arms, it shows that you're very free and you are confident right now at that particular time. और वही आप देखिए, इमेजिन कीजिए जब कोई आदमी ऐसे डरा हुआ रहता है, then their hands are closed, their body is also completely closed. That is brain to body because of something happened and then the body is responding because brain is like. The reverse is also true. Like people say, like, if you are going to have extended arms, okay, if you are going to have a smile on your face, and if you say to yourself something, then brain will start thinking in the same terms. Okay, so and that is why if you look like for even for sleeping, even for sleeping, if you have a certain routine in mind, na, okay, I will make my table up, like I will set my table, okay, properly. Then I will wash my feet, and then I will like, turn my lights off, and I will put my phone. So then the brain is okay, fine, yep, sone ja raha. Then you will sleep very easily. So these things ना they do actually, they sound very कि क्या सर क्या है, मतलब हम अपने आप को आईने में देख कैसे बोले जी इज इजी, आईने में नहीं बोल, लेकिन फिर भी आप ना दिन भर में बहुत बार ये चीज को बोलिए, जी इज लाइक बोर्ड्स, जी इज लाइक बोर्ड्स, जी इज लाइक बोर्ड्स, ठीक है, जी तो हलवा है। अब जब तक इफ यू आर गोइंग टू सी दीस थिंग्स, देन योर ब्रेन विल एक्सेप्ट, देन आपका अप्रोच अपने आप चेंज होगा, यू डोंट हैव टू डू मच थिंग्स। ठीक है, तो प्लीज इस पे थोड़ा सा अप्लाई कर लीजिएगा, ठीक है, थोड़ा सा। बाय द वे ना, दीज थिंग्स ना, थोड़ा थोड़ा हम आपको एग्जांपल देने लगे तो बहुत टाइम लग जाएगा, बट डू यू नो द इंडियन प्लेज? इंडियन प्लेज होता था आप लोग के स्कूल में? इंडिया इज माय कंट्री, ऑल इंडिया आर माय ब्रदर्स एंड सिस्टर्स, होता था? होता है, ठीक है। व्हाट इज द यूज ऑफ दैट प्लेज? एक तो प्लेज आपने लिख दिया है, ठीक है ना? अच्छा, इंडियन कॉन्स्टिट्यूशन भी उसको तो हम नहीं पढ़ते ना, बट व्हाई डू वी रिपीट दीज थिंग्स डेली? To instill those concepts in our brain, to instill those values in our brain. ठीक है? So all of these, whatever you are going to say now, it has effect. It is going to have effect in your own body as well as in the others body who are surrounding, है ना? अब ये हम पॉजिटिव और नेगेटिव एनर्जीज वाले में नहीं जाएंगे, है ना, उस समय, लेकिन बट इट हैज इफेक्ट, ठीक है, आई एम नॉट गोइंग टू लेबल इट एनीथिंग, बट दे हैव इफेक्ट। चलिए, थैंक्स। ये भी बोर्ड्स का ही सवाल है, दिस इज आल्सो फ्रॉम बोर्ड्स ओनली। Some answers. Okay, got two answers. Okay, yeah, then Shahid. Okay, I'm going to give you guys 1 more minute. Okay, Maria. दो हम लोगों ने पढ़ा था जब हम इन द बोर्ड्स, एक तो आपका ऑर्डर फॉर मिथाइल सब्स्टिट्यूएंट एंड फॉर इथाइल सब्स्टिट्यूएंट, ठीक है? मिथाइल और इथाइल का दो केस हम लोगों ने पढ़ा। सो हियर वी आर गोइंग टू लुक एट द मिथाइल केस। टाइम इज ओवर। So in the methyl glaze it was the 2 degree is the most one, then you have 1 degree, and then you have the 3 degree, and then you have the NH3 obviously. इथाइल के केस में थोड़ा सा ये था 2 था, फिर उसके बाद 3 था, फिर उसके बाद 1 था, उसके बाद फिर NH3 था. ठीक है. So which one is going to be the correct option here? C option. 2 degree amine, 1 degree amine, 3 degree amine, and then you have NH3. ठीक है. So इसको लिख लीजिए. By the way, these is in aqueous medium. एक और सवाल आता है in gas phase. ठीक है. In gas phase it is 3 degree, then 2 degree, and then 1 degree. ठीक है. Because वहां पे solvent effect नहीं होता. That is why it is 3 degree, 2 degree, and 1 degree. ठीक है. Please write this down. This is the basic strength of amines. I'll try this. Okay, take 2 more minutes. Your time is almost going to be over. 30 more seconds. Okay, Tarif, time is almost going to be over. Okay. So, hypothetical cyclohexatriene. I will say, what is the cyclohexatriene? Let's make the structure. So you have cyclohexa. That means you have cyclohexatriene. So this is benzene only? No, actually no. When you say cyclohexatriene, that means we are going to be we have only a fixed structure, that is this particular structure. But when we talk about benzene, so benzene is actually this. Actually, benzene is what? The resonance hybrid, which is like this. That means the pi electrons are roaming around. So they're saying that benzene is more stable. Yeah, obviously it is more stable. So this statement is true. And the reason is the delocalized pi electron cloud is attracted more strongly by the nuclei of carbon atoms. That is also true. And that is the reason why it is what? That is the reason why it is more stable. That it is attracted more strongly by the nuclei of the carbon atoms. Okay. So all of these 6 electrons, all these 6 electrons, they are attracted by this 6 nuclei. But यहाँ पे क्या है ना? These 2 nuclei are attracting 2. Two electron pair, and here we have 6 nucleus and 6 electron interaction. So 6 nucleus and 6 electron, obviously यहाँ पे आपके पास पॉजिटिव चार्ज या नेगेटिव चार्ज दोनों ज्यादा है. दैट इज व्हाई अकॉर्डिंग टू द कूलम्स लॉ फोर्स ऑफ अट्रैक्शन क्या वो ज्यादा होगा ना. F is equal to K into Q1 Q2 upon R square. Q and Q2 are what? Zyada. That is why what will happen? This will be having a higher magnitude. Now, so we'll say that assertion and reason both are true, and R is the correct explanation of the assertion. Okay, so B option will be correct. Moving on. Try this. Which will undergo deprotonation most readily in basic medium. तो A, B या C. अब इसमें आपको देखना है कि कहाँ से you have to remove hydrogen atom, ठीक है? And when it gets a negative charge, it should be most stable. चलिए, please try this. I will give you 2 minutes for this. You have to remove the hydrogen atom and put the negative charge. कहाँ पे negative charge आसानी से आएगा? ठीक है? You have to do those stuff. I know this is a bit difficult. This is actually JEE mains level question. ठीक है? मतलब only if you have not done this type of thing in 11th standard. Basically 11th में इस तरह के अगर आप लोगों ने नहीं किया, बोर्ड्स में नहीं रहता जनरली. But it is conceptually easy, so don't worry. Yeah. I'm still giving you time. थोड़ा सा आप लोग दिमाग ऑन रखें. Okay, time is almost over. See you guys. In these structures, if you see, so in this structure we have people. There are no further 4 bonds taken care of. If you look at the first carbon and the third carbon, and you want to remove hydrogen from here, so it will get a negative charge. So 1 and 3 are same, so I will ignore the 3. I'm just saying 1 and 2. This is a negative charge. Now this negative charge will be stabilized by only this oxygen atom, which is having, there will be resonance here, na? A double bond, P single bond, and then there is a negative charge. But if I remove the electron from the second carbon atom, then what will happen? If you see, I will get a negative charge on this carbon atom, and this can show resonance with this oxygen atom also and this oxygen atom also. So obviously, this will be a better place. Now let us look at the other places. Okay. So again, I will not look at this methyl, because these are not going to be as acidic. This B carbon here, this carbon and this carbon we will be seeing. ठीक है. Now the problem with the is that when I get a negative charge here, now this carbonyl carbon, it also resists this oxygen atom because there is also a lone pair here. This can go here and this can go here, right? So here what will be happening? Here there will be, I will say, there will be some deviation, I can say, or this oxygen atom, it is showing resonance with two different atoms. So that is why the contribution towards stability of this negative charge will be very less. But here, both the oxygen atoms are only and only doing resonance with the negative charge, and that is why the stability will be higher. In the C case also, if you get negative charge here, this oxygen will be with this negative charge, but this oxygen will be doing a resonance with this oxygen atom as well as with this negative charge. So A is the only option where the deprotonation is most readily in basic medium. And when they are saying most, na, to B or C तो होगा नहीं because they are not same structures. ठीक है, तो A is going to be the most one. यहाँ से आपको सबसे ज़्यादा होगा. ठीक है, तो A and then C and then D is the odd. Because in A we have two oxygen atoms, two carbon carbons. Take care of one.